Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. This is my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the IIT JAM Mathematics 2024. And in this video, we discuss one problem from the section Algebra, that is from the group theory, and the question bears a serial number 12 in the question paper. And this question is suitable for all these examinations, in particular to the aspirants of CSIR NET Mathematics exam and GATE Mathematics examination. Right. The given question is, consider the group G is equal to the set of all A belongs to M2 over R, the set of all 2 by 2 real matrices such that AA transpose is equal to I2, that is the 2 by 2 identity matrix with respect to the matrix multiplication. Let ZG is equal to the set of all A belongs to G such that AB is equal to BA for all B belongs to G. That is, ZG stands for the center of the group G. Then the cardinality of ZG, the cardinality of the center of G is, we are given four options. Option 1, option A 1, option B 2, option C 4, option D infinite. Right. Let's now discuss the solution of the problem in detail. We have the group G. G is equal to the set of all A belongs to M2 over R such that AA transpose is equal to 2 by 2 identity matrix. It is the group of all 2 by 2 real orthogonal matrices. Right. And A belongs to G will imply AA transpose is equal to identity, will imply determinant of AA transpose is equal to determinant of I2, will imply determinant of A multiplied by determinant of A transpose is equal to 1, but determinant of A transpose is equal to determinant of A. This will imply determinant of A square is equal to 1, and determinant of A will be plus or minus 1. We all know that the determinant of an orthogonal matrix is plus or minus 1. Anyway, we have shown here. When determinant of A and A is orthogonal, when determinant of A is plus 1, they will represent rotations. And when determinant of A is equal to minus 1, they will be reflections. And rotations are r theta, rotations corresponding to theta is equal to the 2 by 2 matrix, first row cos theta minus sin theta cos theta, and these are orthogonal matrices, and there are reflections denoted by S suffix theta. For every theta belongs to R, it is given as cos theta sin theta minus cos theta, where theta belongs to R. These are the orthogonal matrices. For various values of theta belongs to R, these are the orthogonal matrices. Now what we see is, if you take R0, that means you take R theta, substitute theta is equal to 0, it will be 1, 0, 0, 1. Cos 0 is 1, sin 0 is 0. So that is why it is 1, 0, 0, 1, which is identity matrix. And when theta is pi, R pi will be cos pi is minus 1, and this will be minus 1, 0, 0, minus 1, which is precisely minus the 2 by 2 identity matrix. These are these are coming from the rotations. Rotations are orthogonal matrices. These are orthogonal matrices. They belong to G. They belong to G. And moreover, I2 and minus I2 belongs to the center of ZG. Why? Because identity matrix and minus identity matrix, they commute with every element of G. Therefore, they belong to ZG. Now, our question is in Z. Now we say that in ZG there will be at least two elements, I2 and minus I2. Now the question is, are they only two matrices that are present in ZG? If it is so, then the order of ZG, the cardinality of ZG will be 2. And we will probe into what are the other elements that are there in ZG. So for that, what we do is, let us take A is equal to A, B, C, D, be a 2 by 2, be any element of ZG. Any element of ZG we have taken. We have taken any element of ZG. Right. Now, that means A is in the ZG, center of G means AX is equal to XA for all X belongs to G. That means it commutes with every element of G. Now we take X is equal to S naught from reflections corresponding to theta is equal to 0. S naught is cos theta. Cos 0 is 1. Sin 0 is 0. Sin 0 is 0. Minus cos 0 is minus 1. So S0 is 1, 0, 0, minus 1. And X is equal to R pi by 2. That means in R theta, substitute for theta is equal to pi by 2. Cos pi by 2 is 0. Cos pi by 2 is 0. Minus sin pi by 2 is minus 1. Sin pi by 2 is 1. So 0, minus 1, 1, 0. And taking X as this one and X as this one, and we take AX is equal to XA and find what is the possible form of A. Right. So, let X is equal to S naught. S naught is 1, 0, 0, minus 1 belongs to theta. So, AX is equal to XA commuting. Right. So, written A, written X, written A. Multiply. We are familiar with the multiplication of 2 by 2 matrices. Now, equate the corresponding entries. Then you will get minus B is equal to B and C is equal to minus C. That means B is equal to 0, C is equal to 0. Agreed. That means the form of A will be B is 0, C is 0, A is A0, 0D, a scalar 2 by 2 scalar matrix we got. Now we take X is equal to R pi by 2, that is 0, minus 1, 1, 0 belongs to G, yes. And AX is equal to XA commuting. So write A, write X, write X, write A, multiply. This is what we got. And equating the corresponding entries, we get A is equal to D. Then this becomes, the scalar matrix will become this diagonal matrix will become the scalar matrix A0, 0, A. Right, A0, 0, A. But now further, A, this form, that is an arbitrary element. We have taken ZG from ZG, and that will be basically an element of G. Right. So that means A transpose is equal to A transpose multiply is equal to identity. Then you will get A square is equal to 1. A square is equal to 1. That will imply A is equal to plus or minus 1. Right. When A is equal to 1, capital A, the 2 by 2 matrix, is the identity matrix, and when A is minus 1, capital A is the minus I2. So this analysis will tell you, A is ABCD is any element of ZG. That element A is none other than I2 and minus I2 only. So that means to say ZG precisely will contain these two elements only. So thus ZG consists of just these two elements I2 and minus I2. Agreed. Therefore, the cardinality of ZG, that means the number of elements present in ZG, is 2. So let's look at our options. So the answer 2 appears against option B. Therefore, the answer to this question is option B. And that is the detailed discussion of the solution of this problem related to the center of the group of 2 by 2 orthogonal matrices. And it's a good question, definitely. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Yeah, this is my channel. Please subscribe my channel if you have not already subscribed. Yes, I will certainly meet all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.